Section E. Sir Isaac Newton.
Newton went to college at Cambridge, but in 1665 the school was closed to help prevent transmission of the plague. Newton spent the next year in his uncle's farmhouse out in the middle of nowhere.
In the year and a half he spent in the farmhouse, Newton performed some of the most incredible intellectual feats of human history.
He created calculus.
He discovered the laws of motion.
He began to formulate his ideas on the universal law of gravitation.
In that same period of time, Newton also performed one of the most boneheaded feats in human history.
He didn't publish his work or tell anyone that he was doing it, and then he lost all his notes and documentation.
20 years later, Newton's friend Edmund Halley stopped by to visit. Halley and his buddies in London had been trying to figure out what force could possibly hold a planet in an elliptical orbit. Halley asked Newton to help them figure that out. Newton said,
I already did that.
As I'm sure you can imagine, Halley was a tad bit surprised. Through several months of convincing, Halley persuaded Newton to publish his work. Newton remembered what he could and published it in a book called Principia. Principia contained all of Newton's work, and we'll go over it here, except for the calculus, that is.
No calculus?
So now we'll go over Newton's work on the universal law of gravitation, the three force laws, and the spectrum of light.
Newton's law of gravitation was the culmination of the work of Copernicus, Tycho, Kepler, and Galileo. It explained how the heliocentric system worked. Gravity is the force that can hold planets in elliptical orbits around the sun. Gravity is the force of attraction between two objects due to their mass.
Newton's law of gravitation states that the force of gravity between any two objects in the universe is equal to the mass of the first object multiplied by the mass of the second object multiplied by a gravitational constant, all divided by the square of the distance between the two objects.
Okay, that's the textbook definition. What it means is that bigger things have more gravity, and you feel more gravity the closer you are to a big thing. We'll go over this some more later when we do more examples.